Good morning, dear students. In this last video, we have seen about geometrical isomerism. Now, here it is conformational isomerism. Conformational isomerism exists in carbon-carbon single bond, that is in alkenes. Right? It experiences free rotation about carbon-carbon single bond. Right? That means it can freely rotate into 360-degree rotation, which is termed as conformational isomerism. Yesterday I told that in double bond what happens, the carbon which is at the upper will remain stagnant, that is it will not rotate, and which is at the bottom it will try to rotate, but because of the two bonds present they will experience hindrance. But here what happens, it is single bond, so if upper carbon remains stagnant, but if lower carbon start rotation, what takes, it can see, it can completely rotate like this fully. So 360-degree rotation is possible, right? This side, this is the holder of the lead. Now you can see when it rotates, it's completely coming this side and it can rotate, right? So this is the 360-degree rotation that is called conformational isomerism, right? We will discuss more about when we will exactly learn about the alkanes group, right? Now we will go further about the electron displacement in covalent bonds. Now, as we are learning about organic chemistry, right? In organic chemistry, there are hundreds of reactions, and to memorize all these reactions is very difficult. But the thing which we have to keep in our mind is about the functional group present on the particular carbon chain, because organic compounds are basically formed because of the presence of carbon. So whatever the functional groups are present on the carbon chain and the reaction which takes place, it is because of the functional group. Whatever the side chains or substituents are present, they are not considered when the reactions are taking place. They are just considered as copy paste from reactant to product. The exact thing which we have to keep in our mind is for the functional group reagents, right? And when we are talking about covalent bonds, because organic compound, basically it is because of the carbon and hydrogen chain, and carbon undergoes covalent bond by sharing the electrons. So electron displacement will take place. There won't be any donation or gaining of the electron, but there will be displacement. Now displacement, it means movement will take place, shifting will take place, and more precise word is delocalization of the electrons. Delocalization, that means the local place of the electron will be disturbed or it will be changed, right? So this electron displacement in covalent bond in organic compound is studied by some effects, because if we will be able to understand the effects, we will be able to understand the reactions which we are going to learn in next chapter as well as in +2, that is in your 12th standard, right? So let us see the first effect, that is the inductive effect. Inductive effect is a permanent effect. Permanent effect, it means it is present in all organic compound when it undergoes the reaction and when they have electronegative element attached to them, and so it is termed as permanent effect. It is present, inductive effect is present in all compound where an electronegative element is attached to the carbon chain. Electronegative element, electropositive and electronegative. The elements which are donating the electrons are electropositive, and those who are gaining the electrons, they are electronegative. And whenever in organic compound electronegative element is attached to the carbon chain, then definitely the inductive effect is there, that is permanent effect. See, here is an example: CH3 CH2 Cl. Cl is highly electronegative compared to this alkyl group, right? So it is always electron seeker. It will gain the electronegative. So what this chlorine will do, it will try to drag this electron cloud towards it, because it is already paired. Bond is already there, so it is paired electron and bonded. So chlorine will try to drag the electron cloud towards it, and due to that, what happens, the shared electrons will try to get dragged towards chlorine, and so it will acquire partial negative charge, and the carbon very next to the attached chlorine will acquire partial positive charge. The farther the carbon, that means from this chlorine, this carbon is little farther, so it will acquire less positive charge, so it will be double positive. And if carbon is still farther like this, then it will acquire double positive, right? Still farther, it will acquire triple positive. And it is said that after fourth carbon, that means as carbon goes farther, the partial charges decreases, and after the fourth carbon atoms, the effect is considered 0. So what is given here? Here chlorine is more electronegative, so it will attract the shared electrons and will acquire partial negative charge, that is delta, small delta negative, and the carbon to which it is attached, will acquire positive, partial positive, small delta positive, right? As carbon goes farther, the partial charge will decreases as partial 1, partial 2, partial 3, partial 4, and then on it will be 0. After fourth carbon atoms, effect is 0, right? So here electrons are going away. See here, electrons are going away from carbon chain. From carbon chain they are going to the chlorine, because chlorine is more electronegative, and because of this type of effect remains, because of this electronegative element, it is inductive, that is it is inducing the dragging effect. That is why this effect is called inductive effect. It implies its effect. The process of displacement of sigma electrons towards the saturated carbon chain due to the presence of polar covalent bond at the end of the chain, it is inductive effect. The process of displacement of sigma electrons because it is single bond. So the process of displacement of the sigma electrons towards the saturated carbon chain due to presence of polar covalent bond, it is been dragged, then which is present at the end of the carbon chain. This is the carbon chain, at the end it is present. Then this effect is inductive effect. It is denoted as I effect, right? And there are two types of I effect. It is positive I effect and negative I effect. Now, what is positive effect? Positive inductive effect is because of the electron donating groups. Here is an example of electron gaining group. Chlorine is electron withdrawing, electron gaining. It's not donating. But instead of this, if electron gaining group is present, then the effect is positive, right? So if we say this is the electron negative group, that is withdrawing group, so it is I minus effect, right? Let us see here. In this case, displacement of electrons takes place towards the carbon chain. In I effect, what takes place? I effect, that is positive. In positive effect, displacement of electrons takes place towards the carbon chain. Here I told it is negative because it is not towards the carbon, it is towards the chlorine. Electron donating groups are all alkyl groups in which all the primary, secondary and tertiary carbon groups are present or considered. It means electron donating groups, the reactivity decreases because why it decreases? Electrons are given to the chain. When electrons are given to the chain, then the reactivity of the groups decreases. And if electrons are taken from the chain, that means if easily we give something to others, our stability, our reactivity will not take much more power, so it is decreased. But if we are going to drag something, if we want to drag मतलब छीनना है हमें, right? So if we want to drag something, we want more reaction. So when electrons are taken from chain, then reactivity decreases. But when electrons are given to the chain, वैसे ही आपको दे देना है, then the reactivity decreases. You are not supposed to put your effort. So, and whatever you have, you are just giving. That means your reactivity is decreasing. But when you want to take, you want to drag, as chlorine is dragging, so it needs more effort, and so its reactivity increases. And this is the negative I effect. It is the effect in which displacement of electrons take place away from the carbon chain. When the electrons are displaced from chain towards the electronegative group, then it is minus I effect. The electron withdrawing groups are, which are the electron negative groups? They are the halogens, fluorine, chlorine, bromine, iodine. We have just seen a general example of chlorine. Hydroxyl group, OCI3, phenoxy group, OC6H5, nitro group, cyano group, carboxylic acid, ester groups. These are all electron withdrawing group, right? And alkyl groups, in which consist primary, secondary and tertiary, they are all electron donating group. Now, as these all are the electron withdrawing group, whose electronegativity is more, that means whose withdrawing power of electron is more, that order is given here. The order of electron withdrawing power is nitro is having highest electron withdrawing power, then cyano, carboxylic acid, ester, fluorine, chlorine, bromine, iodine, halogen family, alcohol, hydroxy, phenyl, then hydrogen. And order of electron donating, who is easily able to give the electrons, then the tertiary carbon is the highest, then the secondary, right, and then the primary. Clear? So this was about the inductive effect. In all organic compounds, wherever the electron withdrawing group is present, there we definitely find its effect on the carbon chain. And wherever the donating functional group is present, there also we definitely find the effect of the effect on the chain. And so this effect is called permanent effect because it is there in all organic compounds. The next is electromeric effect. It is not permanent, it is temporary effect. It comes in action if there is a reagent present. So if reagent is present, then and only then electromagnetic effect takes place. And the second condition is it always present in multiple bonded systems. If the system is multiple bonded and along with the multiple bonded, if reagent is present, then and only then electromagnetic effect takes place. Multiple bond, if we say, then it is either C double bond C, that is alkane family, it may be with the keto family, it may be with the alkyne family also, right? Electromagnetic effect are also of two types as inductive effect. They are also positive and negative. Let us see here positive electromagnetic effect. Positive electromagnetic effect is denoted as positive E, or we just can say it is plus E effect. Plus E effect takes place in carbon double bond carbon. So here carbon double bond carbon is here. You can see here that this electron, pi electron, see whenever the double bond is there, right, the first electron, as when we have studied about hybridization sp3 to sp2, right, and sp, in that I have explained that whenever the bond takes place, the very first bond is always sigma bond, head to head overlapping, and then side to side overlapping gives the second bond, that is the pi bond. And if triple bond is there, then another will be also pi bond. So this pi bond, shared pi electron, will be transferred, or we can say delocalized, is shifted from this to this carbon, and on the same carbon the reagent which is present, it is attacking on that same carbon. So here the pi electron is giving the negative charge here. At the same time this positive charge is attacking, and it attacks on this carbon and gives us the addition reaction as C single bond C, with all four valency of this carbon satisfied, 1, 2, 3, 4, right? But here you see 1, 2, 3. This carbon only 3 valencies is fulfilled. So what will happen? One valency is unsatisfied and it will acquire the positive charge, right? So what is here in positive E effect? Here double bond consists of one sigma and one pi bond, as I just explained over here. The pi electrons can delocalized. It means it moves, it shifts from one place to another. This, it will shift from one place to another, and in doing so I just told that the same carbon is attacked by the reagent also. So here the fulfillment of 4 valency takes place. Here one unsatisfied, so positive charge is acquired. So what we can say here, the reagent is added and we got the product like this. So this is also termed as addition product reaction, right? This is addition product formed over here, and so we can say that in multiple bonded systems reaction, always we add some reagent. In multiple bonded system reaction, always we add some reagents, and so it is called addition reactions. The effect in which, so from this what we can see, the effect in which electrons of the pi bond are transferred to the atom to which the attacking reagents finally gets attached. See here what is given, the effect in which electrons of the pi bond, right? This is our pi bond. So electrons of this pi bond are transferred. Where they are transferred? to the atom to which the reagent is attacking and gets attached. This pi bond is transferring its electron to this carbon atom. The same carbon atom is attacked by the reagent. So hydrogen is attacking and then gets attached also. First it will start getting here, it will start fighting. Attacking, that means start fighting. So this hydrogen reagent will start fighting with this carbon and then it makes its own place also there. It gets attached there. Then this effect is called electromeric effect, right? In which the attacking reagents finally gets attached. Then it is the positive electromeric effect. Clear? So please go through the videos and properly and try to understand properly, right? We'll do the negative electromeric effect in the next video. Clear? By the time. Thank you.